Hey guys, welcome back. We're going to talk a little bit about thin layer chromatography and photoisomerization. So let me get some markers. And now thin layer chromatography is the process by which molecules move up through a piece of paper. So the way that looks is we have a beaker. Let me turn off the sound. We have a beaker, and we put some liquid in that beaker, and then we put the thin layer of piece of paper in the beaker, like so. You know, lay it up against the side of the beaker, and then after a while, the molecules will move up through the piece of paper, like I don't have an analogy for that. You just have to do it yourself. Grab a beaker, grab a thin layer piece of paper, and do some thin layer chromatography. But what happens is after you pull out the thin layer of paper, you're going to see a diffraction pattern of molecules that separate out up through the piece of paper. So this might be your sodium, and that might be your manganese, and that might be your americium. That's an actual element. They use it in smoke detectors. So americium, by the way, americium, for those of you who don't know and how it's used in, how exactly americium is used in smoke detectors, americium undergoes alpha decay, which means it emits a helium nucleus, and there is a laser inside your smoke detector that that is the laser, the emission of alpha particles through that little hole. If smoke gets in the way, then that will deflect the americium particles, or the decay thereof, and therefore trigger the alarm. So that's how smoke detectors work. All right, now let me talk to you a little more about thin layer chromatography. So back to our drawing here, where we have the piece of paper and all the elements settled out. Now, there's a more advanced machine called a gas chromatograph, in which you can inject the particular substance that you want to analyze. It spins that substance through a copper coil over and over and over, thus separating out the lighter elements. And then what you can do is, once you look at the analysis of the gas chromatograph, it peaks at certain parts, like so. And you can tell how much of your solution was a certain amount, or rather, you can tell how much of your solution was a particular element versus another, or what ratio those two elements were in that substance, or that solution, based on integrating the area under the curve. So for instance, this might be twice the area that we see here. So twice the area underneath this curve there's twice the area underneath this curve than there is underneath this first curve. So we know that there is twice the amount of this material, that element, in that substance. Okay, it's been 3 minutes, 3.5 minutes. Rich, you want to talk about Riemann sums? Okay, Rich, you're not really being a team player here. We need you to be in the video. Okay, just shaking his head and not being a team player. So, you're not being a team player, Rich. Get in the camera. Get in the camera. We need you. We need you. What do you mean, come on? If it's just me recording for 5 minutes, I'm doing my damn job. What do you want me to keep tutoring?
Riemann sum.
No, it's not chemistry. Okay, so let's talk more about chemistry. So we have there's a molecule called alpha methylstilbene. It's got a double bond carbon between the second and third carbons, and I have no idea what's attached to these. Maybe they're like, benzene rings or something. And that double bond is very strong. It's a very strong double bond. Now, the way you can get it to isomerize, that is, get it to switch from trans to cis, is by applying a lot of heat, which excites the bond and causes it to switch to what's called cis, the cis state. So we've basically gone from trans to cis. Now, it's really hard to get it to go to cis because cis is a very unstable configuration. The trans has these benzene rings as far apart as possible, so it's a very stable form there. In fact, most in a solution, you would see mostly. All right, it's fucking 5 minutes. I gotta cut this now.